This is geometry for the spring benchmark practice. We have 15 questions. Let's dive in. And number one, we have a transformation, and it's described by taking every x-coordinate and changing it to 2x and changing every y-coordinate to negative 2y. Whenever you have this type of question, I highly recommend making a graph. So if I were making a graph on the coordinate plane, I can draw a random point. Let's go ahead and draw one here at 1 comma, maybe I'll come up to 2. So this is 1 comma 2. And let's see what happens. So x will change into 2x, which means this x coordinate is going to come out by a factor of 2. I have changed to the x coordinate 2 instead of 1. And then for the y coordinate used to be a 2, but now I'm going to multiply by negative 2, which means 2 is going to turn into a negative 4. So I can come down here to negative 4, 1, 2, 3, 4. And that's going to be my y coordinate. So there's my new point. It's going to be 2 comma negative 4. With 1 point, it's kind of hard to see what's going on. I highly recommend choosing some other random point. Maybe I'll choose the point negative 1 comma 1. So let's come over here to this point, negative 1 comma 1. What happens to each of these x and y coordinates? The x coordinate is going to be multiplied by 2, which means the x coordinate was negative 1 and it's now negative 2. So I'm going to come over here to negative 2. And the y coordinate used to be 1, and now it's going to be a negative 2. So if I multiply 1 by negative 2, I come down here to this point. I guess it's this point over here. And I now have negative 2 comma negative 2. So you can see that this point went down here, and this point went down here. It's a little bit hard to see what's going on, but let's look at our options. So all of these have options of a reflection, and we can choose between a reflection over the y-axis or a reflection over the x-axis. I'm noticing that this seems to be flipping over this line right here, which is the x-axis. So I'm thinking it's a reflection over the x-axis, not the y-axis, not the y-axis, which eliminates A and C. All right, so if it's a reflection across the x-axis, what else are we doing? So a dilation is another way of saying that it grows bigger or it grows smaller depending on what the scale factor is. A scale factor of 1/2 means it shrinks, and a scale factor of 2 means we multiply by 2. And it's even kind of clear to see just in this equation that we are multiplying everything by 2. So the correct answer here is B. All right, and number 2. We're considering this right triangle, and we need to determine whether each statement is correct. We have to select yes or no for each option, so I'm essentially going to be something like that. That's my end goal. So let's go ahead and figure out what's going on. So sine of B, so that means our angle of reference is up here. So if I take sine, let me write out my SOHCAHTOA. Sine is the opposite over the hypotenuse. So in this case, sine will be the opposite over the hypotenuse. Just as a way to remember this, if this is my angle of reference, opposite means across or on the other side. I like O for other side or O for opposite. All right, so that means that sine should be 24 over 26. So it should be 24 over 26 if I did this correct. And I can reduce this fraction by dividing both the numerator and the denominator by 2. I can turn this into 12 over 13. So this is not 12 over 13, so this one is a no. And I'm curious, is there any other sine of B? None of these other have sine of B, so I can't use 12 over 13. I mean, I'm seeing like a 12 and 13. Maybe that one's it. Okay, so let's check cosine of C. So with cosine of C, it changes the angle of reference to down here. So let me go ahead and erase my O and my angle of reference. The hypotenuse will always stay the same, so I can leave that here. So cosine, according to SOHCAHTOA, is adjacent over hypotenuse. So adjacent means next to. So this is the leg that is next to, therefore this is the adjacent. And if I'm doing the adjacent divided by the hypotenuse here, I should be having 24 over 26. 24 over 26, which again, I can see from the previous problem should have been 12 over 13. This one is 13 over 12, so this one I'll write as 12 over 13. Again, this one is a no. Hopefully one of these will be a yes. Let's see, sine of C. Sine of C, the angle of reference is still down here, which means this is the adjacent. Sine, however, is asking for opposite over hypotenuse. Opposite, again, means other side. So I'm going to go on the other side and say, okay, this is the opposite is 10. So therefore, it's opposite, which is 10, over the hypotenuse, which is still 26. That hasn't changed. And again, I can divide this one by 2. I guess I didn't really write the 2 up here, did I? And this is going to be equal to 5 over 13. And hey, that is correct. It is 5 over 13, so this one is a yes. And then finally, we're going to do cosine of B. So cosine of B, again, the angle of reference changes from C to B, so I need to erase my A and O, change the angle of reference to up here. Let's figure out what we need. Cosine requires an adjacent and hypotenuse. Hypotenuse we have, adjacent means next to, so it's the leg next to. So this is my adjacent, and this one would be across on the other side, the opposite. So if I'm doing cosine, I'm doing adjacent over hypotenuse. I'm doing 10 over 26, and this is going to be 10 over 26. And as we can see above, it's the same thing as 5 over 13, which again is the correct answer. On first glance, it might seem that, oh, okay, these two can't be the same thing if they're different functions, but they can be. All right, move on to question number 3. Question number 3 is going to be a proof. So let me read along. So Alex proves that the length AD, so this length right here, AD, or that line AD, is the same length as BC. Okay, so this leg, or not leg, but this side and this side are the same. I mean, on visual inspection, that seems to be true. And the proof is shown. So here is Alex's proof. So it also gives us some given information. So E happens to be the midpoint of AB. So here's AD. E is halfway in between. And it also says that E is the midpoint of CD. So E is the midpoint of this line right here. Okay, that again looks good. And here, let's read the proof. E is midpoint of AB, which is literally what is given. So the reason given, that makes sense. And it says that this line segment AE is the same, is congruent to the line segment BE. So AE and BE, these two line segments are the same, and that makes sense because a midpoint equally divides them in half. Next, we have CE and DE are congruent. CE and DE are congruent. Again, those make sense because E is the midpoint, and it says a definition of a midpoint. Okay, this is something new that I wasn't expecting. So we have the angle of AED. AED, that's talking about this angle right here, is congruent to the angle BEC. BEC, this angle over here. So it's trying to say, let me annotate this. So far we have said this angle and this angle, or this side length and this side length are congruent. We've also said this side length and this side length are congruent. Now what we're saying is that this angle right here and this angle right here are congruent. Okay, and I agree because vertical angles is whenever we have that X shape. Next, it's going to say that triangle AED, this triangle right here, is congruent to this triangle BEC. Do we have enough information? I assume we do, yeah. So why can we say that these two triangles are congruent? That's essentially what we're asked to find here. And then finally, it does prove that AD and BC are congruent because if these two triangles are indeed the same triangles, if they're the same triangles, then this part and this part are the same because they're the corresponding parts. So it says corresponding parts of those same triangles are the same. Okay, so the only thing that we need to do here, what is going on here? We have a side and an angle and a side. That kind of gave away. I did it in the correct order too. You don't say, oh, there's an angle and a side. That's not even an option. But it can't be side, side, side because one of these is talking about an angle. So it's super important to know what was proven here. And let me go ahead and write this on the proof. We have a side here, and an angle here. It doesn't matter the order that it's being presented to in this proof. It matters the order in terms of the annotation on the diagram. So either way, I had an angle, and this one doesn't have any angle, so it can't be A. This one is saying that there's two angles. Clearly, there's only one angle, so this one is incorrect. And I'm kind of, oh, whoa, these two options are exactly the same. Angle, side, angle, angle, side, angle. That is definitely a typo because I made this to mock the real test. Let's go ahead and say, let's change this one to side, side angle. It'll be fixed in future years, because I think that would be a common mistake that students would say, oh, side angle is the order in which it's given in the proof. That is incorrect. The correct answer is D, angle side angle, because the angle is wedged in between the two sides in terms of the order of which they occur in the triangle. All right, moving on to question number 4. All right, we're considering this right triangle, and we're determining whether each statement is correct. Okay, so we have to find sine of B. Okay, so sine of B, I'm going to write out my SOHCAHTOA again. SOHCAHTOA. SOHCAHTOA. And I need to find sine of B. So if this is the angle of reference, this is my adjacent, this is my hypotenuse, this is my opposite. Sine is asking for opposite over hypotenuse. It's going to be 3 over 5, and indeed it is 3 over 5. This is a yes. It's asking for tangent of C. Okay, because the angle of reference changed to C, I'm going to have to re-diagram everything. Okay, I'm going to skip down to this question right here because it's the same angle of reference. Tangent of B. Well, tangent is opposite over adjacent. Opposite over adjacent should be 3 over 4, and this is indeed 3 over 4. So I'm going to go ahead and mark yes for now. Now that the angle of reference has changed here, I need to swap the places of O and A because my angle of reference is up here. That means on the other side, the opposite is 4 and the adjacent is 3. So now I can ask this question, what is tangent of C? Tangent, again, is opposite over adjacent. Opposite is 4. Adjacent is 3. So it should be 4 over 3. This one is 3 over 4. So these are backwards, which means this one is a no. And we saw the same angle of reference down here in cosine of C. So cosine of C is talking about U, which means we're doing adjacent over hypotenuse. It's going to be 3 over 4, and 3 over 5. And this one, again, is backwards. So this one needs to be flipped. Therefore, the answer is no. You have to do that for every single problem. Whenever it says sine of B, you have to actually find it and see if it matches that value. It's essentially asking 4 problems all in one. All right, let's move on to question number 5. Okay, so we have a word problem. We have triangle 1. I don't like word problems because it makes me draw the picture. I'm going to draw a picture. So there's a triangle 1. It's probably, I'm just going to say it's not to scale, right? Obviously, because each of these angles is 60 degrees approximately, and it's clearly saying one of them is 27. But that's okay. Okay, I'm saying one of these angles is 27. I'm just going to say this angle right here is 27 degrees. And it also has an angle that measures 80 degrees. Okay, not to scale, but it also has this other angle that's 80 degrees. Okay, now I'm talking about a second triangle, so I'm going to go ahead and draw a second triangle. Triangle 2 has an angle that also measures 27. Okay, so that these two angles are the same. So this angle is 27 degrees. I'm going to go ahead and say that those two angles are the same. And it also has an angle that measures A. I could put it right there then. Oh, but it says A is not 80 degrees. So instead of putting A right there, what if I put A right there? Here, let's go ahead and put A degrees up here. Based on that information, some guy named Joe claims that triangle 1 and triangle, there's a typo here, and triangle 2, I'll fix that in future years. Again, I made this kind of late. 1 and 2 cannot be similar. Okay, what value of A in degrees will refute Joe's claim? So there's 2 parts here. What does it mean to be similar, and how can we show similarity? The first thing, similar just means 3 equal angles. And because we know that a triangle adds up, the sum of the interior angles of a triangle add up to 180, really, we only need 2 equal angles, because we can find the third and prove that that third is also equal. So if we can find 2 equal angles, we're ready to go. That will prove similarity. So we are missing an angle. Notice it gave us 27, 80, and we are missing U. So I'm going to find that missing angle in triangle 1. This is triangle 1, that was triangle 2. So in triangle 1, I have 27, I can't write here, 27 plus 80. That adds up to 107 so far. And some missing angle, which I'm going to call x. So plus x plus x. That should add up to 180. You can see that we're missing x. So I'm just going to really quickly subtract 107 on both sides. So x is going to be, what is that going to be, 73. So up here, I'm going to label this 73 degrees, which means if I change this angle to 73 degrees, then by default, this one has to be 80. So Joe, unfortunately, you are wrong. You said that these two triangles cannot be similar. You forgot that this angle we don't know. So, well, I guess we could figure out. So it's 73 degrees. So we'll say 73 degrees. If that's equal to A, that will refute Joe's claim. And I realized that I glanced over this hard word, refute. Refute means it will go against. It means that Joe is wrong. So that's that fancy word, refute. All right, number 6, Charlie. He's designing a skateboard ramp, and it's shown in that diagram. All right, so we need to figure out the ramp height in inches, and we're going to round to the nearest whole inch, so the nearest whole number. So we just have to solve for h. Again, this is implying that we're going to be using trigonometry. Anytime we have a right triangle, we can use trigonometry, and I need to figure out what to do here. So again, if you don't remember SOHCAHTOA, S-O-H-C-A-H and T-O-A, I need to figure out which of these I'm given. So if I go on the other side, if I go on the opposite, I have the h. So this is actually an a. Don't be fooled, that's not the hypotenuse. The hypotenuse is clearly the more diagonal one, or the one that is across from the 90-degree angle. This one is the hypotenuse, and therefore this one is the, whoa, why did I say a there? This is the opposite. I said opposite, and I didn't write it down. Opposite, on the other side of the angle. That means this is the adjacent, and this is the hypotenuse. There we go. So notice that we have no information on A, which means this A and this A we cannot use, which means we are forced to use sine. So I'm going to say sine of my angle, which I happen to know is 25. Sine of 25 will be, and sine is opposite over hypotenuse, it is going to be opposite over hypotenuse, or h over 135. H over 135. And from here, we're trying to solve for h. So how do I get rid of divide by 135? I multiply both sides by 135. Multiply by 135. Multiply by 135. And I get h. H is equal to that number. This type of question implies that you'll need a calculator. So let's go ahead and get a calculator ready to go. I'm going to split the view, pull up a scientific calculator. Let's put it on the left-hand side since I'm right-handed. I don't want to write on top of the calculator. I'm going to type in 135 sine of 25. And I get about 57.053. And again, it said round our answer to the nearest whole inch. So this will be 57 inches. All right. And just as a reminder, in case the actual benchmark that you take has the variable in the bottom, the way that you'd get rid of the variable on the bottom is you switch the diagonals. Let me give you a quick example in case there's not an example later on. If I have something like, I'm making up a problem. Let me use an entirely different problem, like tangent. The answer was tangent of, maybe it was 31. I'm making up an entirely new problem, is equal to 5 over x. The way that you solve this type of problem is you switch the diagonals, because technically that's over 1. You'd switch this x and this tangent of 31, so it becomes x is equal to 5 divided by tangent of 31. I'm not sure if that's what's going to happen on the benchmark, but I do know that these are the two possibilities that you can have, right? All right, we're moving on to question number 7. I can pull back that calculator if I need it. Consider this right triangle. Determine whether each expression can be used to find side PR. This is a lot more difficult of a question because I need to do multiple steps to check each of these. Again, this is 4 problems all baked into one. So I'm noticing that this multiple choice question is only using cosine and sine and no tangent, which makes it a little bit easier. So I'm going to write out my SOHCAHTOA, S-O-H-C-A-H-T-O-A. And let's go ahead and find what is cosine, what is sine. And notice they changed the angle of reference here on us. So I'm going to first do the angle of reference Q. So we're going to say that the angle is here. On the other side, I have an opposite, I have an adjacent, and I have a hypotenuse. I'm noticing that in order to find side PR, I'm going to go ahead and call this side length permanently. It's going to be x for the entire problem. I'm trying to solve for x. I'm trying to solve for this side length PR. So you are going to maybe be equal to that one. I don't know. We'll see, right? So I'm going to set up an equation where I use hopefully a 17. I don't know. Okay, let's try sine first. So how do I do sine of Q? Or I guess cosine was first, huh? We'll do cosine of Q. Cosine is the adjacent over hypotenuse. So with Q, it's going to be the adjacent over hypotenuse. We can say that cosine of q, in this case, is equal to 15 over 17. And that could be used to solve the q. Did we ever even include an x? Did we ever include side PR? The answer is no. There's no way that this equation somehow has an x in it. Therefore, the answer is no. Let's try another one. Let's try sine of q, because I have a sine of q right here. Sine of q, let's do that, is equal to, sine is the opposite over the hypotenuse. Oh, look, an opposite has an x in it, so maybe this will be the answer. It'll be x over h, or x over 17. X over 17. Okay, well, at least we're on the right track. Now let's do another step. How do we solve this thing so that we get x by itself? Because all of these are claiming that they solve for x. To undo divide by 17, we'll multiply both sides by 17. Multiply by 17, which means x will be equal to 17 sine of q. And as we can see, that is not right there. And these are sine of r and cosine of r, which means this answer was never used. And there's no way that you can use sine of q other than using this one equation, which means you are wrong. Let's try another one. Let's try cosine of r and cross our fingers here, right? So let's do cosine of r. Now our angle of reference has changed. We're not doing q, we're doing r, so I need to erase my a, erase my o, erase my angle of reference. H will always do the same. My angle of reference is now up here, which means opposite is 15, adjacent is that x. So cosine of r, remember, cosine is the adjacent over the hypotenuse, or a over h. It's going to be x over 17. So I'm going to come down here and say x over 17. To solve for x, I multiply by 17 on both sides, and therefore x is equal to 17 cosine of r, which is exactly what is written here. This is a yes. Finally, we have 17 sine of r, which I'm doubtful is the right answer, but just to work through the entire problem, again, I'll say, how do we find sine of r? Because that's the trig function that they're using here. Sine of r, using SOHCAHTOA, sine is the opposite over the hypotenuse. Opposite is 15, hypotenuse is 17, so it's going to be 15 over 17. And we have the same problem that we had up here, which is there was no x down here. There's no x there or there. We can't solve for x, so that one is unsolvable. I mean, it is solvable for capital R, but I'm not trying to find capital R. I'm trying to find x. All right, so let's move on to question number 8. All right, this one is one of the trickiest problems in this entire benchmark, so be careful. We're going to say cosine of 60 equals a half, which is a true statement. You can punch it into your calculator and be like, oh yeah, that's true. But here's the thing. We need to find an angle measure in degrees for sine of theta. There's two ways to solve this. There's the way that is with a calculator, which I assume we have a calculator for this problem. And there's the harder way, which is just knowing trig properties, which I don't do a very good job teaching. So I'm just going to cross my fingers and hope that you have a calculator in this problem and show you what to do. So I need to find the angle here. It's kind of silly. We don't actually need this if you have a calculator, because what you're allowed to do here is you can just solve that one equation. To solve for this equation, I undo sine. The way that I undo sine to both sides is I take the arc sine. So if I have this function, let me go ahead and rewrite the problem. This problem is sine of theta is equal to, I'm going to give some room here because I know it's about to happen, 1/2. I'm going to take arc sine of the left side, and I'm going to take arc sine of the right side. When I do this, arc sine and sine cancel each other out, solving for theta, which is the thing it's asking for. What is the angle measure theta? And I can just say, what is arc sine of 1/2? Hopefully we have a calculator, and we can just go like this. Arc sine of 1/2. We'll come over here, and we will go to the functions. Arc sine is sine to the negative first, and I can just type in 1/2. And the answer here is 30. 30 degrees. Okay, the question here is why? How would you do this if you did not have a calculator? I'll talk about that as well, since I I know how to do it. Let's go ahead and pretend we know exactly what sort of triangle they're talking about. It's this right triangle right here. We happen to know that this angle is 60 degrees, and this angle, therefore, is 30 degrees. Why do I know that? 90 plus 60 plus what equals 180? 30. It's a 30, 60, 90 triangle. In this case, it's saying cosine of 60, which means our angle of reference is the 60. If that's the angle of reference, this is the hypotenuse, this is the opposite, this is the adjacent. We know that for a fact. Using SOHCAHTOA, which I will write again, SOHCAHTOA, using SOHCAHTOA, we know that if I set up cosine, cosine will be the adjacent over the hypotenuse, which means the adjacent is 1, the hypotenuse is 2. Kind of interesting, right? We know that this adjacent is 1 and the hypotenuse is 2 because it tells us that cosine is the fraction 1 over 2 using SOHCAHTOA. So here's the cool thing. We are still talking about the same triangle in the same problem. Now it's saying, hey, I want to get a half and use sine, but I don't know what angle to use. What angle should I use? Should I use that angle? Should I use that angle? Is there some other way of doing this? And here's the trick. We know that sine is opposite over hypotenuse, so we need to do an opposite over hypotenuse. What is the angle of reference if this is an opposite over hypotenuse? I can't, again, this is a little bit backwards, but we need to essentially say, we need to erase the A and erase the O because we don't know what the angle of reference. Choose an angle of reference that you want. Maybe try that angle of reference. It changes the letters now. This is the opposite. This is the adjacent. Now, sine is the opposite and adjacent, or opposite and hypotenuse. Opposite and hypotenuse are 1/2, which is what we were supposed to use. Therefore, the answer for the angle that we were supposed to use, the angle of reference, was supposed to be 30. All right, so let's do number 9. This one is a very straightforward problem. We know that the angle of reference is right here. We know what SOHCAHTOA is, SOHCAHTOA. And we know that the opposite is on the other side. The hypotenuse is the one that's opposite of the 90-degree angle. And we know that the adjacent is right next to it. So we need to find the length of FD. We're trying to find FD. We're trying to find this length right here, which means this is the X. I need to set up some trig function that relates information that we know 14, with x. 14 and x are the two lengths that I'm trying to use. I do not want to use this length. I don't care about DE. It doesn't say anything about DE. Do not use this length. Do not use O. Do not use O. Therefore, by default, we have to use cosine. So we'll say cosine of our angle 62 degrees will be equal to, and cosine is adjacent over hypotenuse, therefore x over 14. X over 14. From here, we just solve by multiplying both sides by 14, multiply both sides by 14, and there's our answer, which means this is a calculator question. You have to use a calculator. We'll come over here and say, what is 14 cosine of 62? And it says round to the nearest tenth, which means 1 decimal place. 1 decimal place is 6.6. So this number, I'll write it down, the rounding to. This x is going to be equal to 6.573, but if I'm rounding to the nearest tenth, then this is going to be 6.6. All right, number 10. Considering this right triangle, determine whether each expression can be used to find the length of FH. So we're trying to find FH. Might as well label that the x that we're trying to find. Let's go ahead and dive right in. Again, sine of h is telling us we need to use sine, and we're talking about this angle of reference. If you haven't figured it out, again, we're writing out SOHCAHTOA over and over. SOHCAHTOA. Pro tip on the benchmark, you'll have a spare sheet of paper off to the side if you ask for it. You can write it down just once instead of writing it down over and over again. We're using the sine, which means we're talking about the opposite and the hypotenuse, which means the opposite over here and the hypotenuse right here. If I set up my sine function, sine of h will be 20 over x. Okay, remember, I finally get to do a problem where we switch the diagonals. Whenever I have an x in the bottom, the way that we solve for that is we switch the diagonals, and if I do that, x is going to be 20 over that sine of h. And check it out, this is exactly what's written here, like right from the get-go. That is a correct answer. All right, I'm seeing cosine of h, which I want to try right now because I don't want to change the angle of reference here. Cosine of h means I'm doing the adjacent over the hypotenuse, and the adjacent is down here, so I'm going to say that's the adjacent. If I set this up, let's go ahead and say this is going to be cosine of h should be, again, adjacent over hypotenuse, 21 over x, 21 over x. And again, the way you solve this is you switch the diagonals. Therefore, x will be equal to 21 over cosine of capital H. Unfortunately, that's not how this one is set up, so that one has to be wrong. This is the only way that you can solve the problem with using cosine of h. Let's try using cosine of f. Cosine of f is using a different angle of reference, which means I need to erase all of this and say that my angle of reference is up here. Therefore, this is the adjacent, this is the opposite. And I'll write cosine of f. So cosine, again, is adjacent over hypotenuse. It is a over h. It's going to be 20 over x. 20 over x. From here, again, because the x is in the denominator, I'm going to switch the diagonals, and x is going to be 20 over cosine of f. 20 over cosine of f is exactly what's written here, so this one is a yes. And I have a feeling that this is going to be wrong because tangent doesn't even feel right. Notice that tangent of f is still talking about, this is the angle of reference. Tangent is the opposite and adjacent. Opposite is 21, adjacent is 20. You never even used x. You can't solve for x if you never use x in the equation, so this one doesn't even make sense to use. All right, that was question number 10. Let's move on to question number 11. In number 11, Morgan is designing a handrail for a staircase and needs to determine what length the handrail will be. So I'm trying to find the length of the handrail. I'm going to label that x. The top end of the handrail will be 11 feet above the bottom of the handrail. It already labeled that for us. And the angle of depression, okay, this is a keyword that will come up again later in the test. We might as well learn it now. Angle of depression means the angle, if I stare off straight in the distance and I change to look down a little bit, it's this angle right here. So that angle of depression is 43.7 degrees. And we want to find x. So what is the length in feet of the handrail? And we have to round to the nearest whole foot, nearest whole number. So solve for x. How do we solve for this problem? Again, write out SOHCAHTOA, S-O-H-C-A-H-T-O-A. We know that we have an angle of reference that is at that 43.7 degrees, which means my opposite is 11, my adjacent is this length that we don't know, and my hypotenuse is the x. We do not want to use that information. We only want to use information that's relevant to us, namely the handrail and the 11 feet. We need to use a trig function that relates h and o. H and o is this one right here. It's sine, so let's set it up. We say sine of the angle that we know, 43.7 degrees, is going to be equal to opposite over hypotenuse, 11 over x. 11 over x. Yet again, we have one of these problems where x is in the denominator and we need to swap these diagonals. So swapping these diagonals means that we have x is equal to 11 divided by sine of 43.7. From here, we can, again, use our calculator. Let's pull that back up and type in 11 divided by sine of 43.7. And the answer here is x is equal to 15.922, if I'm rounding. But what are we supposed to round to? We're supposed to round to the nearest whole number, which means this 15.9 gets rounded to a 16. All right, 16 feet. I don't think you ever need units on the benchmark, but just in case. All right, number 12. We have triangle ABC, which is similar to LMN. This problem, I think, is super tricky if you don't know what's going on. We need to circle all angles, which means we can circle like as many as we want, that have a sine of 8 over 17, which is super weird. Okay, I'll tell you why that's weird. Because this angle and this angle are obviously not the same angle. I can't just say bottom right and bottom right. I need to do the tiny angle and the tiny angle. So if I'm circling corresponding angles, these two angles are the same angle. All right, so that's nice, but I'm going to ignore this triangle for a second and purely focus on this. If the answer is A, that means the answer is also L. If the answer is C, that means the answer is also N. That's the point I'm trying to get across. Okay, so from here, let's go ahead and pretend, yes, the answer is A. That means that sine of A should be 8 over 17. Is it? I don't know. Write out SOHCAHTOA. 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 If I'm talking about angle A, that means my opposite is 8, my adjacent is 15, my hypotenuse is 17. Sine is talking about the opposite over hypotenuse, 8 over 17, and I should have 8 over 17, which indeed I do. I got it right on the very first try. It is A. And I told you, if it is A, it is also the other tiny angle, L. So it's A and L. I think that's probably all I can have. You can never take sine of a 90-degree angle, so it doesn't make sense to talk about B or M. Another possibility is C. Let's go ahead and look at it. What if we do sine of C? What happens here? That changes the angle of reference to up here, which means I need to erase those. The angle of reference is here. The opposite is 15. The adjacent is 8. Let's check. If I do sine of C, sine is the opposite in hypotenuse. Opposite is 15, hypotenuse is 17, and this should be equal to 15 over 17, which is not 8 over 17. Therefore, that one is also incorrect, and we have our correct answers of A and D. All right, moving on to question number 13. Consider this right triangle, find the length of WX. So if I'm trying to find the length of WX, let's label that X, which is funny because I used X already, but that's okay. I'm trying to find that length right there. So how do I find that? Again, I have my angle of reference, which means my opposite is here. Let me change the color coding here. My opposite is X, my adjacent is 15, and X, or I was going to say X, H is the hypotenuse. All right, write out SOHCAHTOA. So SOHCAHTOA is written. I know I'm not using H. I have no idea what's going on up here. I don't want to use it. I want to relate something I'm trying to find with something that I know. X and 15 are O and A, which function uses O and A. That one right there. I'm going to be using tangent. Tangent of my angle, which is 27 degrees in this case, should be equal to O over A. O is X, A is 15, so it's going to be X over 15. The way that we solve for X is we multiply both sides by 15, multiply by 15, and we get our answer if we had a calculator. So let's pull that back up and say, what is 15 times tangent of 27? And the answer here is 7.643, I guess, if I'm rounding, is about equal to X. What are we supposed to round to in this problem? In this problem, we're rounding to the nearest tenth, which means 1 decimal place. So it's really 7.6. All right, in number 14, Taylor is climbing to the top of a monument. Looks like it says top of 311 feet, so we know the height is 311 feet. Looking down, Taylor sees a friend who's standing at point B. So the friend, I guess there's a stick figure right here. There's a friend down here. Find the measure of the angle of depression. Again, I told you this word would come up again. It's asking for this angle right here. This is the angle theta that we're trying to solve for. Okay, so let's go ahead and again write out SOHCAHTOA and label our triangle. We know that the adjacent is going to be 100, the opposite is going to be 311, and the hypotenuse is this thing that it's the line of sight from Taylor to Taylor's friend. So I need to somehow relate something that I know with something that I don't know. I'm going to be using the 100 and the 311. I'm using A and O. I'm using this A and this O. Therefore, I'm using the tangent function. So tangent of the angle, which we don't know now, is just theta. And that's going to be equal to, I know eventually I'm going to get rid of tangent by writing arctangent here. So I'm giving myself room to write arctangent, and I'm going to write the fraction right here. The fraction is O over A. O is 311, and A is 100. Okay, I need to undo tangent. The way that we undo trig functions is taking the arc of that trig function. So this is going to be arctan of tangent. And if I do arctan to the left, I also do arctan to the right. These two cancel each other out, leaving behind theta, and theta is that number, which again, we need a calculator for. So let's pull that back up. We say, I need to type in arctangent, which again is tangent to the negative first for whatever reason, of 311 divided by 100. And that angle is 72.175. What were we supposed to round to? If I always just do 3 decimal places at the very beginning, then I can always round it down later. It says round to the nearest whole degree, which means the whole number. This is going to be just 72 degrees. 72 degrees. All right, we are on to our last problem. Sam wants to determine the height x of a nearby tree. Okay, it's a word problem and I don't have a picture. I'm going to make my own picture. So I'm going to go ahead and say I have a tree. There's my very fancy drawing of a tree. Okay, we need to figure out the height of a tree. So I'm trying to figure out what is that height right here. And Sam stands 53 feet away from the base of the tree. So Sam, I'm going to put you right here. And this distance between Sam and the tree, we said was 53 feet. The measure of the angle of elevation. Okay, this is a word that we haven't defined before, but elevation means go up and depression means go down. So this angle from here and then looking up. So this angle right here. And I'm going to do a dotted line. So this is the line of sight to Sam. This angle right here happens to be 21 degrees. Okay, select all of the following that can be used to find the height of the tree. Oh my goodness, we have to check so many things. All right, things that are interesting to me. Most of these are 21, which makes sense. Some of these are 69. Where are they getting the 69 from? Oh, maybe they're doing, maybe they're doing that angle right there, which you can do. You're allowed to do. Is that angle even 69? So if I do, that's a 90 degrees, which means if I have 180 degrees for all three of these angles, 90 of them are used up, which means I only have 90 between these two angles. So if I do 90 minus 21, I can get this angle up here. That's going to be, it is indeed 69 degrees up here. Okay, so we have a lot to check. Let's see what's going on here. I'm just going to use tangent of 21, see what happens. And notice I'm checking tangent of 21, tangent of 21. I'm checking both of these at the same time. So if I do tangent of my angle 21, that means my angle of reference is down here. That means my opposite, I'm going to put my opposite over here, my adjacent over here, and my hypotenuse right here. Tangent, I have to write out SOHCAHTOA. I'm going to write it up here because I have some room. SOHCAHTOA. Tangent is opposite over adjacent. So opposite over adjacent is x over 53. So this is going to be equal to x over 53, which means to solve this, I would multiply by 53, multiply by 53. Therefore, x would be equal to this 53 tangent of 21. And that is not u, but it is u. It's 53 tangent of 21. It's not a, but it was d. We did kind of two problems at the same time. Let's check cosine of 69, which unfortunately is not repeated, so I only have to do it once. Let's try. Let's see what happens. So let's do cosine of, I changed my mind. I don't want to do cosine of 69 because it changes the angle of reference. Let's save those 69s until the very end. This 21, I'm going to do right now because I want to figure out with the same letters O and A. So cosine is talking about the adjacent over hypotenuse. That means I'm going to be talking about this 53 over something that we don't know. This doesn't make sense. If I'm doing 53 and something that we don't know, x has not been included in the equation, which means this cannot possibly be correct. X wasn't even there. What about sine of 21? Sine of 21 means I'm doing opposite over hypotenuse. I'm doing opposite over hypotenuse. So this one does make sense to use because it uses x, but unfortunately, this relates two things that we don't know. We do not know the hypotenuse, and we do not know the x. I have to relate something that I know, something I know, and something that I don't know. I'm doing something that I don't know, something that I don't know, with something I know. There's too many unknowns. So this one also does not make sense. All right, so now we can talk about the angle 69. So if I change my angle of reference, that means that my opposite is going to be down here, my adjacent is going to be up here, and we can finally talk about cosine of 69, which is going to be adjacent over hypotenuse. It's going to be this adjacent over this hypotenuse. Again, this runs into the same problem of these are two things that I don't know. You can't have two unknowns in an equation unless you have two equations. We only have one equation, so we cannot have two unknowns. This one is incorrect. This one feels maybe correct. We'll see. Okay, so sine of 69. Sine is the opposite over hypotenuse. Opposite is 53. Hypotenuse is h. Unfortunately, this one also doesn't work because it didn't even include the x. So this one is not included, which means there's only one answer. Even though it said select all, which meant there could have been multiple answers, there was only one answer, and it was answer letter D. Wow, okay, that was a bit of work for the spring benchmark practice for geometry. I'm going to go ahead and flip through each of these pages in case you're just looking for the answers to check your work really quick. All right, that concludes the spring benchmark practice for geometry. Thank you for watching.